Hi guys, so today I'm just going to show you another approach on how to write the equation of a hyperbola in standard form given its vertices and the asymptotes. So I'm just going to label this really quickly. The vertices are points. You have the xy point, which can be both positive or negative 16. Now, since everything is happening on the y-axis here, that means that you will have a vertical axis to deal with. So that means to start it off, we already have the equation y squared over a squared minus x squared over b squared equals 1. So just dealing with this equation, I'm just going to note what I have so far, which is the x and the y. So the y would be 16 squared. I don't technically know what a and b are yet, but I do know that this equation will have a relationship with a and b. So we're just going to keep that in mind. And x is going to be 0, so 0 squared over b squared equals 1. Now, the nice thing is 0 squared is 0, and 0 divided by anything is still going to give me 0. So you can write 0 here, or you can just get rid of it altogether. Because I have 16 squared over a squared. If it's minus 0, it's still just going to be 16 squared over a squared. Drop down that it equals 1. And 16 squared would give me 256 over a squared equals 1. Using my algebra, the only unknown here is a, so I'm just going to isolate it, multiply both sides by a squared. And I have a squared equals 256. And to get a by itself, I get rid of the square by square rooting. And keep in mind the positive and negative is already compensated for, so I'm not going to write that down, but I know that a is equal to 16. So with that stated, I know again that there's a relationship between this equation and a and b. So for 4 to become 16, I would have to multiply it by 4. So that's going to be the same correlation here. That means this relationship to get to b, that would give me 28. So I know that a is 16 and b is 28. All right, guys, that's pretty much another method, more of a shortcut method, but I hope it helps.